Let's try this multiple choice problem. It says, in the figure above, two blocks of mass 3m and 2m are attached together. The plane is frictionless, and the pulley is frictionless and massless. So in other words, we don't care about the pulley. The inclined portion of the plane creates an angle theta with the horizontal. What is the acceleration of block 2m if both blocks are released from rest? Gravity equals g. And so we've got our choices right here. But let's figure this out. And I'm going to set this up kind of like a textbook problem. On the real multiple choice test, you would probably not go over it quite as thoroughly. So here's 3m. I'll put wheels on it just to show that there's no friction. And here's a pulley. So we've got a rope and a pulley. And then we have this 2m thing like this. And we've got this angle theta. And this is what's given. What are we trying to find? Trying to find the acceleration. Now it says the acceleration of block 2m, but they're hooked together, so the acceleration is going to be the same for both masses. Now, what I would do if I'm looking at this problem on a multiple choice test, you got to go fast. So I'm just going to, whenever I see a fixed pulley like this, I redraw it. I go, okay, we got this, we got this. I straighten out the free body. But what is this? Like if I draw a free body diagram here, we've got the tension force here. We've got normal force, okay, like this. And we've got force of gravity. Oh, force of gravity is like this. So here's the normal component of gravity, but here's the component of gravity that's trying to pull it down. And that's going to be, the opposite of that's going to be 2m times g times the sine of angle theta. Now, does everybody see why it's the sine? Okay, look, you got to take this gravity force, mg, well, it's really 2mg, right? And we got to break it up into its normal component and its parallel component. Well, if this has been inclined up theta, then theta is right here. And so this is the opposite leg. When you break that force into its components, you get that. Now, this one has forces on it too, right? We've got the normal force, we've got the force of gravity, and then we have this tension force. But this tension force is internal to my free body diagram. So there's only one net outside force acting. It's 2m g sine theta. If I sum the forces acting, that equals ma. But what is the total mass? Well, 3m plus 2m is 5m times a. And so I'm going to divide this by 5m. Okay, and so the acceleration I get, well, the mass cancels, so I get 2/5 g sine theta. And that hopefully is on the list. 2/5 g sine theta, so the answer is B. Did you get B? Did you get that answer? Answer B. So what's the big idea? First of all, oh, thank you. Big idea. The procedure. You can see it now. I didn't really show it very thoroughly because I only have a little over a minute to do each multiple choice problem. So I can't thoroughly go through the problem. But I did use the procedure. I drew a free body diagram. In my mind, I drew an XY axis, and I did all that. So make sure that you know that 5-step procedure for forces. Okay? And then, for pulleys that are fixed, straighten the free body. Make sure you understand that idea. And then, of course, well, it's part of the procedure. But, you know, sum of the forces equals mass times acceleration. Okay, so you need to, that's step 4 of the procedure. Okay, any questions on this problem? Took me 5 minutes to explain it, but that's the way it goes. That is nicely done.